Hello everyone, welcome back to my channel. So now we are done with all the questions which are from text in between the text, and now we are going to do exercise questions. Once again, it's for class 11, chapter 1, which is some basic concepts of chemistry. After completing the exercise, we are going to focus on a few questions which are coming in the competitive exams from chapter 1. So be ready for that also. Okay, so we are going to do first question, that is calculate the molar mass of the following. So it is very easy, we have already done it. Okay, so we are just going to revise it, and please follow along with me. First is H2O. So as you know, there are two hydrogen atoms and one oxygen atom. You should know what is the atomic mass of hydrogen, and you should also know that what is the atomic mass of oxygen. So atomic mass of hydrogen is 1 unit, and atomic mass of oxygen is 16 units. Okay, so we are going to put the value in the molecular mass. Molecular mass of water is going to be equal to, there are two hydrogens, so 2 into 1 unit plus 16 unit. Okay, so first you have to multiply it, because according to BODMAS, multiplication is done first. 2 units plus 16 unit, and it becomes equal to 18 units. So the molecular mass of water is going to be 18 units. This is the first question, first part. Okay, second part is molecular mass of carbon dioxide. Once again, atomic mass of carbon is 12 unit, and according to first question, we know that atomic mass of oxygen is 16 unit. Okay, so molecular mass of carbon dioxide is going to be, there is only one carbon, so 12 unit, plus there are two oxygens, so 2 multiplied by 16 unit, which becomes 12 plus 32, and which is 44 units. So molecular mass of carbon dioxide is 44 units. The third one is molecular mass of CH4. This is also known as methane or marsh gas. Okay, so once again, atomic mass of carbon is 12 unit, atomic mass of hydrogen is 1 unit, molecular mass of methane is going to be atomic mass of 1 carbon, which is 12 unit, plus there are 4 hydrogens, so 4 multiplied by 1 unit, and 12 plus 4 becomes equal to 16 units. So methane's molecular mass is 16 unit. This was first question of the exercise. Now let's go to the second question. Today we are dealing with only 2 questions. Okay, so next questions will be done in the next video. Okay, first one, the question, second question is calculate the mass percent of different elements present in sodium sulfate. Okay, and the formula for sodium sulfate is also been given with you. So what you have to do is you have to calculate the mass percent of different elements. So first of all, you should know that what are these different elements present over here. In sodium sulfate formula, there are three types of elements. First one is sodium. 2 atoms are there. Okay. Second one is sulfur, and sulfur has only 1 atom. And third one is oxygen, and oxygen has 4 atoms. Okay. So now we have to calculate the mass percentage of each element. Okay. We should know mass percent formula. Mass percent of an element can be calculated as it is equal to mass of that element in the compound divided by molar mass of the compound multiplied by 100. Okay, so this is the common formula for calculating the mass percentage of an element. So first of all, we should also know that what is the molar mass of the compound. So to calculate molar mass, we have already done how to calculate the molar mass of a compound. So the compound over here is sodium sulfate. So we have to calculate the molar mass of it. 2 sodium are there. So 2 into 23 plus 1 sulfur is there. 1 sulfur weighs around 32. I am taking the approximate values. Plus 4 oxygens are there. 4 into oxygen. 1 oxygen's atomic mass is 16. And when you calculate, it becomes 142 grams. Okay, because we are talking about molar mass, not molecular mass. If somebody is wondering that what is molar mass is simple mass. Simply whenever you calculate the molecular mass, you write the unit as unified mass, okay, or atomic mass unit. But in molar mass, the same number is represented in the grams. So the way of calculation is same, but the answer is written in grams only. Okay. So what we are going to do, we are going to write down we are going to calculate the mass percentage of each element. First we take sodium, okay. Then mass percent of sodium. So there are 2 sodium atoms, okay. So 2 into molecular mass, or sorry, not molecular, atomic mass of the sodium, which is 23, divided by the mass of the compound, which is 142, and it is a percent, so obviously multiplied it with 100. So it becomes approximately 32.4%. You can calculate it, okay. It is around 32.4%. This is the mass percent of sodium. Let's calculate mass percent of sulfur. Mass percent of sulfur. So there is only 1 sulfur, okay, and 1 sulfur weighs around 32 grams, or we are talking about 1 mole of sulfur, so that's why grams, okay. 142 is divided and multiplied by 100. So once again, when you calculate it, it comes out to be approximately 22.5 or 6%. You can calculate it. Next one is oxygen. So once again, mass percent of oxygen. So there are 4 oxygens in the formula. So 4 moles of oxygen multiplied by atomic mass in grams obviously. So molar mass of oxygen, that is 16 gram, divided by molar mass of the whole compound, that is 142 grams, and multiplied by 100. So if we calculate it, it comes out to be equal to around 45%. So these are the percentages of all the elements which are present in sodium sulfate. So sodium is 32.4%. Sulfur's mass percentage is 22.6%, and oxygen's mass percentage is approximately 45%. One thing you should note down, that some of these, all the elements which are present in a compound should comes equal to 100%, or if not 100%, then 99.9% approximately. Okay, so these should be there. Okay, so that we can say, okay, from this particular substance, which is 100 gram of the substance, this gram of sodium is present, that is 32.4 gram of sodium is present, sulfur is 22.6 gram, and 45% oxygen, means 45 gram of oxygen is present. I hope you got to understand that how you are going to calculate mass percent of a particular element in the compound. Thank you so much. Have a nice day.